Hi, Leo Dreger here. Let's talk a little bit about file systems and hard drives. Right? So, some basic types of file systems and hard drives. Right? We have the classic disk type file system, which is, the things that we put in our computers. Everybody kind of knows that one, pretty self-explanatory. They have basically two types, internal and external, but there are other types as well. You have networking file systems, you have database file systems, and countless others that we're going to get into and talk about. Basically, what you need to do is compare a bunch of information about the different types of hard drives. Okay, this is what I call the Rain Man quality. It never ceases to amaze me that somebody always wants to talk to me about hard drives, and they just start throwing out brand names and specifications and expect that I know what they're talking about. And well, to some degree I do, or many degrees I don't. Okay, because there are different factors. There's speed, there's transfer time, there's capacity, and those are rather generic qualities that we look at when we start talking about hard drives and file systems. But then there's also very specifics like brand names and sale prices and things like that frankly are relevant in my world. We have the physical structure. You have track density and areal density. We're going to get into that and discuss how you actually calculate track density or what is exactly areal density. You have the logical structures, right? Everybody should know at a minimum FAT, NTFS, and the EXT type file systems. These absolutely are the most popular ones, but don't discount it, there are many others as well. You have FAT12, FAT16, FAT32. You have NTFS and different versions of NTFS. You have, in the Linux world, very, very popular file systems, the EXT file systems, EXT2, 3, 4, etc. And a variety of others. You have EXF, JFS, Reezer, and countless others. Don't forget, we could even go into the CD versus DVD versus Blu-ray. We could even look at RAID levels and tie in fault tolerance into these conversations. So while the details are vast and verbose, I always try to boil things down to the absolute basics. Some of those are going to be just simply the partitions on these different types of file systems. We typically have primary partitions, which contain all of our boot files, and then we have extended partitions, which are really designed for additional data. We're going to take a close look at master boot record and look at that from a hands-on point of view, and I want to show you how to duplicate a master boot record from one hard drive to the other one if one gets corrupt and things like that. And I'll show you how you can use the unforgiving DD command. I say it's unforgiving because realistically that command will do anything that you tell it to do without asking you for your permission. So if you tell it to do the wrong thing, it will unforgivingly do it. So you need to pay close attention to all of the possible combinations of how to manipulate the DD command. Next, we can go into the file systems and all of the factors there, like the number of tracks or the track density, or how to do sector sizes, or how do you look at the addressing or the file structures, or even how to do a disk capacity calculation, right? While we have computers that'll tell us how to do that for us, it's a good idea to still know how to do that manually as well. Then we can look at all of the interfaces, right? It's one thing to know about the physical structure and the logical structure of the drives, but how are you actually going to connect to them? Is it going to be a SCSI drive or an IDE or the rather outdated EIDE or USB or ATA, SATA or PATA style drives? Or is it a fiber channel, which those are much, much more popular in the data center, where things like SATA are much more popular nowadays in the home market? Okay, and then we'll follow up and we'll end with the different types of boot processes on like the Windows system and the Linux file system, right? And what files are needed and when to use what files and everything you need to know about the different types of files used in the common boot process. Because it's one thing to have a master boot record, it's another thing to actually know what that master boot record's doing, what files is it referencing, manipulating, changing, what are the order of those files based on the different types of operating systems and architecture. So this is a very, very verbose and detailed section. So let's take a closer look with a little bit more hands-on approach. Hey, Leo Dreger here. I want to show you a really cool utility. In some cases, you have encrypted files, which you'll find, and you just want to learn some basic information about them and about the encryption process of these encrypted files. So I happen to have a folder here called Leo, but I'm actually logged in as an administrator in Leo, and I am the owner. But I want to point that out because that has nothing to do with this lab and where I run this tool. I happen to have a tool, a command line utility that I copied just to the folder I'm working in called EFS info, okay? And the location in which this is being run is 100% arbitrary. I can run this from anywhere that I copied this utility to. Just want to point that out. So it just happens to be easier to run it from the directory because it tells you the current directory that it actually is encrypted, and then the users who can decrypt this based off of Windows encrypting file system is the actual owner at this computer. If you're using a naming convention in your computers, therefore you can track who logged onto those computers and correlate key information based on trying to track down the original owners of the encrypted files. That's what you would be doing when you would be using this tool to try to correlate large bodies of information. Hope you enjoyed. Well, actually, you know what? There's way more. Let's do this. Let's go look at the help file, okay? Displays information about encrypted files. Not only does it tell you what it does, but it displays the user information. You can do a -R recovered agent. All right, so let's just have some fun with this. ESF info /R. Spell it correctly. EFS info -R. In this case, no recovery agent found. So this one did not find a recovery agent for the directory that I'm working in. Let's do -C. Okay, encrypted information, users who can decrypt this particular agent and the certificate thumbprint number. So that's going to be real helpful because that's going to match exactly to the certificate of the user. So it's those exact numbers that correlate in your forensic evidence that proves custody here. All right. The password.pxf file, that's encrypted, users who can decrypt it, and the certificate thumbprint right here. Okay, so everything. Then you can do a -I. Okay, same thing here, so no help. Then there's K, keys and algorithm information. Okay, let's see what that tells us. Okay, in this case, the files were actually encrypted with AES 256-bit encryption. Okay, for both of the pieces. Let's go back up. Y, your current EFF certificate thumbnail. So if I just want the thumbnail in itself, Y. Here it is. Whoop, digital thumbnail. Okay. The S, perform a specific operation on directories in the given directory and all of the subdirectories. Okay, so that means kind of like a recursive option. We're not going to do that because there is no subfolders. -T touches all the EF files in the given directory and all the subdirectories used to update the EFS key information on the encrypted file system. Okay, well, you could do that, but it's going to effectively be the same as before. Oh, and then, of course, the directory is the proper format. So C:\Leo. All right. None in this case, which is why I didn't do it in the previous one. But you can prove nothing, right? And then, of course, the last little bit of the help file. So that's it, completely. How is it encrypted? Who encrypted it? Where do I go match that information? All in one little utility. Don't forget to like and share on Facebook, LinkedIn, YouTube, and Twitter. Hey, Leo Dreger here. I want to show you a cool little video. This is going to be a utility where we're going to find stuff that doesn't exist. Okay, we have a USB drive, nothing on it, right? So if we refresh it, doesn't seem to be anything there. If we look at the properties, Okay, you can see some use space 31, but they always have something, so it's not really like you can tell anything. So we just happen to find a drive, nothing on it. Okay, so let's go over here to File Scavenger. So we're going to look for everything. You know, in the drop-down, you got all sorts of stuff that you can select from. If you want, like, just documents, you know, they have a bunch of predefined saves here. You can go through those if you want, but it also takes any searches, like if you want, you know, star.doc, you know, to try to find all those, things like that. Well, since we don't know what we're looking for yet, let's go ahead and select everything. And let's choose the drive. It happens to be the F drive. And if I'm going to do a quick search, hey, no file found. Okay. Scratch your head a little bit. Well, let's try to see if we find it in long file mode. And it says, okay, hey, do you want to skip deleted files and folders? Well, no. Why would I want to skip those? I would want to see what was in those. So, okay, let's go ahead and get those. Okay, now we got something here. Now we got something to go around. Let's see if we can't find anything interesting. Some master file table stuff. Components of a bitmap, it looks like. Some, I don't know, looks like some language here. Right down here at the bottom. Check this out. I'm hidden.txt. All right. I wonder what's in there. Well, you can right-click it and select properties and actually see that it's, you know, the file name of it, where it's located, the master file table record number, and the actual place on the hard drive, the sector number in which it's referenced, and the last access time. Okay, that's pretty cool, right? So there is something on this drive, and you can see it, and you can get access to it right here. Okay. Now when I stop the search, it says abort searching. Okay, yes. Okay. To display files in the Windows Explorer-like format, click on the Tree View button right here, okay? So that's this button right up here. So it's just a little prompt here, but it'll allow you to basically come down here and start seeing what's on the drive and where it actually is. So you can see right here, I'm hidden. Found you. Can't hide from me. I got you. Don't forget to like and share on Facebook, LinkedIn, YouTube, and Twitter. I'm Leo Dreger. Hey, Leo Dreger here. I want to talk to you about Process Monitor. This is 100% a tool that I couldn't live without in my cheap dip computer machines, right? All of my testing machines that I use. It's a great program, comes from sysinternals. Just to kind of give you a highlight, it's got times, it's got the process names, the process ID with the processor, what it's actually doing, like registry queries, a lot of registry stuff you'll see, the path in the registry, the result of that path, and some detailed like, queries or desired access, reads and writes and things like that. So that's kind of like the overview of the columns. Let's look at the properties of something specific like Explorer.exe. Now, you can cross-reference this information with Task Manager. So I want to kind of cross-reference a few things. In processes, or actually performance, you can see threads, handles, processes, uptimes, and this is all of like the high-level overview processor information that we don't normally get to look at in the detailed. What is the actual processes? What are the actual threads? And what are the actual handles? Well, in Process Monitor, you can go to the stack, and you can actually see those. You can see what handles and what files are being referenced, what they're actually doing, the location, and then the memory addresses that they correspond to. And of course, the full path of the file if you really wanted to know where this sits. You're probably fine here with the top 3 rows. So nonetheless, you get to cross-reference
handles, threads, and processes, and actually get to dig down and see this. 99.9999% of the time as a system admin, if you're ever doing anything performance related, you care about this right here and starting and stopping things. Well, in the forensics world, you got to flip that coin and you got to look over here and you got to see what things are doing and how things are behaving forensically. These are the fingerprints that are changing on your system when your system is actually processing. Okay, so I think it's cool that you can actually see that, compare those two values right here, both from the networking point of view, or I'm sorry, system admin point of view versus the forensic point of view. I mean, here you are looking at two screens of two different worlds. So if you're trying to make that transition between, hey, I'm a system admin and I understand things from a system admin point of view, well, what is the forensics person, what's their point of view? Well, that's the cross-referencing. These are the two sides of the conversation that now meet. So hope you enjoyed the lab. If you like these videos, share them, connect. Remember, there's real people behind here, not just computers and videos. So connect with other people, share, tweet, and give it your best. Leo Drager here. I can't even begin to tell you how excited I am about this tool. This tool is phenomenal. You're going to love it. It's Registry Shot. And what it does is it takes a snapshot of a registry and compares the first value to the second value. So we're going to have some cool fun with it. I think this is one of the most novelty programs that is my favorite in the forensics. So I'm just going to take a snapshot of the registry. All you do is open the program, click shoot. It'll go through, analyze the keys and the values, and you can see how long it takes. While that's running, you got an output file. You can arbitrarily leave that wherever you want. That'll only become relevant if you're going to actually save the file and do something with it, or if you're just running it like I am, just to see what's in the comparison, then it doesn't matter. But if you're saving it for an analysis or report, save it accordingly. So what we did is we did the first shot. Now we're going to go install some software, and I'm just going to install some software that I'm going to use later. So go ahead, boom, accept the agreement. Really could call this anything. Finish. Okay, great. Close out of that program. Now back to this one. Now let's take the second shot of the registry. So go ahead, click it, shoot it. So there's two pieces here that you can look at, the academic piece and then the tool piece. So the tool piece we'll talk about when we get there. But the academic piece is realistically when you're setting up your lab environments and you want to determine what viruses, worms, and Trojans or any sort of program does to the system. Like, how does it change the integrity of the system? How is the program manipulating the system? When you install things or you get infected with something, it changes the settings in the registry. So if you have a reference point, a baseline of what a first comparison looks like, and then something bad happens, then you can go and compare that to the second version and get an idea of exactly how that program behaves, okay? So now that it's done, we're going to compare those two. So all I did was take a snapshot, install some software, take another snapshot, let it run, and now let's look at it. Let's see how exciting this is. All right, okay, cool. This file is huge. For one, remember, all we did was install one program. All right, so registry shot, the date and time in which it runs, so it just happens to be right now, the computer in which it ran on, and the owner's information. You can change this for your reporting arbitrarily, just for documentation. I mean, I wouldn't leave that as the default. I would put actually, instead of owner, your name, All right, so but it added 40 keys here, and you can scroll down. You can actually see every single registry hive that was touched according to that software. So in many cases, when software runs, people just install them arbitrarily and they let the wizards run, and they never realistically think about this from an integrity standpoint and what it means to the system. Well, with Registry Shot, you can actually see that integrity change. What exactly was changed? every single registry hive from one state to another. Here's another hive, 127 values. You can see the bulk rename utility, everything, every single key, every single hive, all of the values for those, counter information, and this is just going to go on and on and on and on. But what I would recommend is that if you're going to, build these over a series of time, well, then you can kind of run another program, remove all of the duplicates out of that, and then just leave yourself with a very, very specific set of data that you actually can go after and say, okay, well, this is the part of the program that's behaving in the way that I need to investigate, evaluate, or write the report for. Like, this is the attack. This is it. Okay, this is what got changed. This is exactly what's going on. And now I have the proof to give to the developers to go, remedy that change from a defensive point of view. Right? So that's your offense versus defense. Your CISSP mindset is realistically, I don't necessarily care about the details per se, but it's just the before and the after, and seeing that change of integrity and seeing how the things change and what do we do about it. Not necessarily the technical aspect of it, but how does it get administered, or how do we manage the threat overall, right? So that's it. It's a very, very exciting tool, Redshot. Hope you enjoyed it. And if you didn't enjoy that one, I don't know what you're going to enjoy. That one was exciting, and share it everywhere. Twitter, tweet, go for it. Go nuts. And I'll see you in the next video. Hey, Leo Dreger here. I want to show you guys a cool little scenario. Let's pretend that a user is trying to clean their tracks with Easy Cleaner, and let's do some forensics analysis with Redshot. Okay, so I'm going to open up the programs, run, take a snapshot of the registry, give this a chance to run so we have an official baseline to go with too. I don't really care where the output is because I'm just going to go first shot, second shot, and then compare the two. So now we have a baseline. Let's go to Easy Cleaner. Okay, let's run the program. Okay, yeah. That's actually the install wizard. I want the program. So let's do easy. There we go. I already have it installed. Finish. Okay, we're going to go into the registry here. We're going to find a bunch of stuff. I'm just going to let this go a handful. We're not going to let it run the full registry scan, but let's get enough hives in here to see if we can't compare in our baseline. A dozen or two should work fine for the test. Okay, we should have enough now. So let's select all the files. Let's delete all of the files. Are you sure we want to delete 44 entries? So we should see approximately 44 entries in our list. So it looks like I might have to delete these a few times. So delete all, delete all. Okay. Aborted, 44 invalid entries. It says that they're invalid entries, but we'll see. So let's see if the user actually can clean their tracks. Try to delete them a few times. Now let's take our second shot of the registry. And compare the files. Error creating the file. Great. So I've effectively switched over to the HTML document, and I'm going to compare them this way. And error creating the file. So let's go ahead and change the location. I'm going to go to a directory that we have full control over. So I'm just going to use the labs directory, and then let's go ahead and clear all of these. Let's take another baseline. Now, these are the types of things that you have to do. You have to play with the scenario and get it to work. So just because you want stuff to work on the first time doesn't always mean that it's going to work on the first time. So let's go ahead and find some entries. Okay, stop them here. Delete the 9 entries. It says 9 invalid entries. So let's go back over here and take our baseline. And compare the files. So in that case, the error message that we went through, all right, is changing to a directory that we had full permissions over, and you can see that that did in fact work and fix that problem. Note to self, okay? RegShot, no comments, standard information, the computer, the owner, the values that were modified. So that's pretty consistent. I have 9 invalid entries here, and I have 9 modified entries here. So let's see if they match. Do we have an HKey local machine? No, we do not. Not here. Okay. Do we have, let's search the document for underscore users. Okay. So it looks like there's a underscore user and user assist. Do we have a user assist? Second sanity check? No. So in fact, these are different than what we're seeing. All right. So you can note that when you do analysis. Are they the same? Are they not the same? Do these tools do what they're supposed to do, or are there false positives? Just because you see the number 9 doesn't mean that it's the correct 9. But I could see how easily anyone could just glance and go, okay, 9 and 9, it makes sense. For us, it doesn't correlate whatsoever in this example. All right, so that's a scenario you can go through and you can do your analysis. Do they match? Do they not match? What's the first snapshot look like? What's the second snapshot look like? Comparing something to a baseline, and ultimately working in a lab environment and being able to cross-reference information to, in fact, determine if they are or are not consistent. Thanks for watching. I'm Leo Dreger. Don't forget to check us out on Facebook, LinkedIn, YouTube, and Twitter. Hey, Leo Dreger here. I want to do a tool called HD Valet. This is what we would call a junk file cleaner. Basically just scans your hard drives for, obviously, the things here. Backup files, and if you go to the properties of any one of these, it'll tell you exactly what it does, right? Searches the local drives, searches for files matching these specifications, astrid.back, astrid.old, cleans up files by moving them to the recycle bin. Okay, so you could realistically go through that. It's pretty consistent from what I've seen in terms of everything going to the recycle bin. Specifically, I have the recycle bin empty here. And for giggles, we're going to do this along with registry shot just to see if we can have some fun, see if, in fact, trying to clean your tracks in this faction actually has any effect on the registry from this point of view. Okay, so I'm just going to leave everything checked here, indicative of a user cleaning their tracks and taking any files and trying to delete them, make them go bye-bye. So we're going to go ahead and clean that up. So now testing backup files. It's going to run through its program, and we'll let it run. We'll see how long it takes, and then we'll compare it to the second round in registry entries and see if removing anything from the system actually does in fact affect the registry, or at least this tool.
HD Valet processed 11 junk files and removed 797 junk files. 143 files could not be removed. Check the log file for details. When all of these files are permanently deleted, you will realize the savings of at least 530 megabytes. So it tells us the size. To view the log file, sure. Let's go ahead and look at the log file. Log file, non-existent. Let's look at the recycle bin. Whoops, that's not deleted. Let's look at it. Okay, so it looks like it. Let's change the view here. List details. So I found a whole bunch of stuff in a couple of different drives here. I have a sample drive. Okay, found a lot of real estate files. Most of them are all temp files. So it deleted all of those. Okay, great. Also, you can sort by file type over here. You get some dates and timestamps if you also like. Okay, great. Log file non-existent. And let's take a second shot of our registry and see if it changes anything there. Now, I do have the scan directory listed here, but it's not selected. So I don't believe that this matters in this specific case. So let's compare the files. Okay. Keys added in this case. So current version, Bitbucket volume, something with Explorer here. Looks like a lot of Bitbucket files, multiple user interface caches. Okay, and then you could go through and analyze this and figure out, is this related to our actions or not. I'm not going to spend time on that specifically here. But it looks like more files were actually added to the registry than actually removed from the systems. But we did have several keys or hives that have been modified. So you'd want to go ahead and save that for your analysis later. So, final summary. Took a shot of the registry, took a file cleaner, analyzed the registry again, and while one would think that a lot of things would be removed, actually values were added to the registry. So the moral of the story here is that things are not always as they appear. So thanks for watching. My name's Leo Drager, and I'll see you in the next video. Hey, Leo Drager here. I want to talk to you about a tool called rname-it. Effectively, what it does is it's a bulk renaming utility. And anybody who deals a lot with photos or specific file types that wants to go ahead and rename it, it's easy to use the photo example, because if you take all of your photos with like a Canon camera and all of your pictures come out with a particular timestamp, let's say around the holidays like Thanksgiving or Christmas, while you could just right click each file and go to rename it and add a prefix of Thanksgiving or Christmas or Happy Holidays or whatever you wanted, new baby. What you could effectively do is use a program like this and just do it in bulk. Okay, so I want to show you kind of how one of these programs would work. So you have basically the drive letter and what you can select here. You can show all the files. You can sort the names. Okay, this would be the directory that you're working out of. You can make changes to the prefix, like if you wanted to do, holidays. Okay, you can make changes to the extension, maybe like, JPG or something like that. And it gives you that format right here. So the old prefix, the holidays, .old extension, .jpg, something like that. And then you can preview those files and then rename it, and it'll run through the directories and effectively rename them. So it's a way to change a lot of things on a hard drive at once. And in the scope of forensics analysis, you're often looking for, mass changes. Let's say somebody had a bunch of videos and they decided to hide them by, changing the extension to a text file just so they wouldn't come up in a search or something like that. Okay, so there is application. The utility is rname-it. It's for mass changing one naming convention to another, and it scripts that process. So hope you enjoyed the video. My name's Leo Drager. Don't forget to check us out on Facebook, LinkedIn, YouTube, and Twitter.
Hey, Leo Dreger here. I'm sure you've all connected by now on Facebook, LinkedIn, YouTube, and Twitter. I want to cover a tool called System Information for Windows. I like this tool because it's a very, very detailed, oriented tool that you can run against operating systems to collect all sorts of reconnaissance and enumeration. It kind of just, if you ask me any question about it after running this tool, I should be able to answer it. Okay, so I'm going to run down the list of things that this queries. Sometimes the queries can take a little bit, but nothing more than I wouldn't go get coffee. I would just wait for the query to run. So it's relatively short in the grand scheme of things, right? So you can click on operating systems. You can look at some of the updates. You could immediately connect in here and say, hey, what are the installed updates on the computer? What are the missing updates in the computer? And anytime you're using some sort of inventorying system, whether it be Tivoli or, whatever, right? Just some sort of, I will need to know every host on the network and what does it look like, and give me a status. These questions up until recently were very, very, very hard to answer in the grand scheme of things. You just couldn't ask a question like, are we secure? Are our computers up to date, right? Just because there's so much missing information in conventional reports that you'll never, whatever answer you come up with is only a percentage of accuracy of realistically how close you think you are, right? So nonetheless, we can go into the software, you can get to updates, you can see the missing updates. That's fine if this connects to Microsoft.com. I'm not going to run the specific report on this just because there's way too many other things to cover. You can grab system directories, so any program that's basically in here, as soon as you type it at the command prompt or PowerShell, it's more or less going to run. Because these are all environmental variable set, plus they can map over here to registry keys, which is just, Explorer's shell folders. That's pretty uncommon. So it's a shell folder and it's a shell variable that sets it. Any sort of system files, what directories these are located in, and some examples and details of each one of these, like what's in this file, what's in this file, what's in the host file, So that way you don't have to go navigate all the way to the file through the file directory and grab the host. So the fact that this just tells you saves you clicks, and clicks makes you faster and much more efficient as anybody who has to answer questions for a living. You have LMhost, not that that's really used too much anymore. You got MS-DOS, you got the system INI file, all the items in there, the WinINI file, MS-DOS.sys. You can grab installed programs, so you can get a quick shot of what's installed. Instead of going to Windows Update and seeing what Windows programs are installed, just go right here. Publisher, the version, the date, the key for it if it's set, different applications. If you like doing some application reconnaissance, just pick something, anything in here. DirectX, look at all the properties and the values. Google Chrome, properties and values. .NET Framework, properties and values. SMAC, properties and values, right? So lots of stuff. You want to grab security settings testing. You want to go get a quick vulnerability scan. Antivirus, is it set? Is auto updates set? Is it, anti-spyware? What's the condition, the values? Are the firewall rules even set on? Or does it have antivirus software? Or is it using Windows Defender for spyware? And even here, I love this button here, licensing. I'm not going to show it to you for hopefully obvious reasons here, but the actual licensing piece, it tells you all of the license, and you can write them down. So it does you a quick little license inventory, which is worth 1,000 seconds in itself. Accessibility options and which specific ones are set. So this reminds me of looking at group policy, detail specific settings. Environmental variables and what they are and what they're set for. Regional settings, if you go into this a lot and you work a lot with time zones or locations or geolocations or changes in keyboard layouts or currency. File associations. This is nothing more than going to Windows and right-clicking and going to the file extensions. You should all know how to do that by now, and so that way you can change a file extension when you need to. One thing I love about a tab like this is most often us network people know the inside OSI model inside and out, but nobody ever really has a great example of layer 6 of the presentation layer. This is it, folks. This is where you make the associations. Okay, to determine what layer 7 application actually opens it. But this is directly interfacing with layer 6 of the OSI model, file association. So those of you that Have studied the OSI model in the past, please note, boom, big list, all extensions. Any one of these are fair game. What running processes are on the system? What loaded DLLs, what drivers, what NT services, what auto run features, what scheduled tasks are, what databases. I mean, it just goes on and on and on and on. So let's just call that section, okay, cool, nice software overview. Now let's go to emulated hardware, okay? So in this case, I'm able to pull virtual machine settings, motherboard information, anybody who has an A+ background, right? Watch some of the A+ videos. Anthony did a phenomenal job at those. Go ahead and look at all this stuff. You got BIOS settings, CPU settings, memory settings. This is where geeks get to geek out. PCI settings. Storage devices, what ports, if you're kind of starting to get, and not networking ports, this would be hardware ports because it's under hardware, but networking ports, all your predefined settings, okay? Power policies, can you, from an attacking point of view, can I, attack this system and maybe change a setting like this and force it to shut down, therefore causing a denial of service attack? What are the battery settings, printers, resources, okay? All right, so that'll give you the overview of hardware. I'm going to leave some things clearly off the table here, but I want you to go play with them and you evaluate them and you have a takeaway, right? Because, active learning means doing. So it's one thing to watch me. It's another thing to go do it yourself. And that's the difference between talk the talk and walk the walk, okay? Neighborhood scan. Open ports on the system, the different shares. So this should look familiar. It should look like you just did a net share at the command prompt, and that's what you would get. Or, hey, you could easily net share. Okay, look familiar? Well, I think so. Remote access connections, if there are any. Other networking sections, like a browsing network neighborhood directly built in. And yes, I have a computer named Obi-Wan Kenobi. And search network neighborhood, right? FTP scans. And so it's got a built-in scanner to it. So this is, you want to learn certified ethical hacking? Bam, here you go. Okay? It's just way too much detail. This is stuff that you guys have to look at, evaluate. It's got a built-in network and traffic monitor to it. You want to sit there and watch traffic? Go download something just for the sake of seeing some traffic here, download the combination, boom, let that go, see it spike. This is how you learn. This is how you test things out, right? Use the tools. All I can do is give you an overview of the tool. You have to evaluate the tool yourself and go, okay, and make the relationships, and that's how you're going to master this learning. So stick with me. I've got, a couple hundred more videos left to do. Hi, Leo Dreger here. I want to talk to you about a tool called Add Remove Pro. And effectively what it does is it takes all of the things out of your lists here, add remove, and effectively deletes them, cleans them up. So it's a utility that someone could use to basically try to hide their tracks. And that certainly falls in the realm of forensics and forensics analysis. So when you first launch the tool, it comes up and says Add Remove Pro checks, removes, uninstalls entries in Windows Add Remove Program List. So click on the install button and proceed with the installation. So we'll go ahead and install it. We'll agree to the licensing. We'll put it right in program files. That's fine. And it says setup cannot copy the file Add Remove Pro. So it's retrying. It's not going to work. Cancel. And we'll go ahead and cancel the utility. Okay, so effectively, by just changing the directory, I was able to get Add Remove Pro to install. I haven't normally had problems with the installation of that, so that looks like more of a hiccup and anomaly more so than anything else. So let's go ahead and look at Add Remove Programs. Add or remove programs. We have a whole bunch of stuff here. So you got Add Remove Pro, Advanced Encryption Package, Big Mother, Easy Cleaner,
Okay, all of the add install forensics programs that I've been doing videos on, that's the theme here. Okay, you can refresh the list a couple times if you like. So you can kind of go over the introduction, the accuracy, the status messages. It's basically a tutorial down here on how to use this file, how to find the uninstall strings, how to create backups, all entries, and things like that. So what effectively you could do is you could take something like the program Add Remove Pro and uninstall the program. I should want to uninstall this program. Yes, let's go ahead and uninstall it, the actual program that I'm using, and see if it removes from this list. All right, so looks fine to me. Looks like it's still there. If we hit F5 here, it's still here. Let's see if the uninstall works from here. I should want to remove this specific utility. Yes. Add Remove Pro was successfully removed from your computer. All right, interesting because I still have it open right here. So that just goes to show you, sometimes tools, they work exactly how they sound, sometimes they don't work exactly how they sound, but you get to test them out and evaluate them. In this case, a user would be using this tool thinking that it would be working, and it's actually not cleaning the tracks. So that's the takeaway here. Sometimes it's nice to show programs and how cool they are, but also it's nice to show exceptions and deviations from what you expect normal behavior to be. And there's several of those types of videos, including in here, where the student has to evaluate, does this make sense? Okay, so these are one of the questionable videos in the series.